Okay, now let's delve more into the advanced capabilities of ModularMind. So let's say I want to do an academic research. One of the platforms I use quite frequently is archive.org from Cornell University. And like many other platforms, it has a search bar for me to search for any topic. So let's say let's just search for retrieval augmented generation, which is a method for LLMs to retrieve pre-composed data to prepare their answers to improve their, reliability. And as you can see, it just quickly delivered the results for this particular search phrase. And let's go to advanced search and say, I just want to see the results about computer science. Let's say I'm not interested in physics or economics in general. Again, hit the search button and it gives the results from newest to oldest about retrieval augmented generation on computer science. So I want you at this point, I want you to pay attention to the URL scheme of the page. So there are many parameters here. It says advanced about the type of the search. There's this search phrase we had, retrieval augmented generation, and there are many other things. And it looks a bit complicated, to be honest. But if I copy this link and open it in another tab, let's say I'm using this, I want to go to that exact same page in a later time. And as you can see, I can access that page about that specific search query anytime I want by visiting that link. So this means that I can share this link with ModularMind, so it will be able to visit this exact same page again to generate some results, some outputs for me. So let's go and try that. I'll go there, right click, quickly add a prompt, and let's say here is the search results um, on archive.org. I don't have to explain too much at all. And let's say I wanted to read the page and just give me some information from there. Let's say I want you to write the names, the titles, let's say, of the articles and the names of the writers. I will use GPT 3.5 Turbo for this case because it's a relatively simple task. And let's name the stack as Retrieval Augmented Generation on Computer Science at Archive. Let's run this now. As you can see, it just decided to visit that exact same link because we simply told it to. And it will read the content just like we do when we visit it through our browser and try to come up with the task results we had, which is, the names of the titles of the articles and the names of the writers. Okay, now results are coming. As you can see, it read the content and generating results. Let's check that page again by clicking on that link. So the first one is poisoned rag. The second one is retrieval augmented thought processes, process as sequential decision making, G retriever, and more. So yeah, it successfully went there and read the content and delivered the result to me. It decided to return the first 13 results, but and we can try to improve that by explicitly telling to retrieve more, but we'll just continue with this for now. And this is kind of cool, but it's really not a big deal, right? I can already go there, visit the link myself, and it really didn't bring me any more information than the ones present in this page. So let's continue a bit more sophisticated versions. So let's say I want to convert this simple stack into one that delivers me the results for any search phrase I might have, not only retrieval augmented generation. So let's simply duplicate this stack and say, I want to search about, or say, search a term LLM agents. And let's just, not to confuse the model, take this prompt from here to add it as a separate prompt at the end. So it's not confused about when to do what, right? So we will just first say search for LLM agents, then write the titles of the articles and names of the writers. So let's run this again, and let's say it's about anything on CS at Archive now. Let's run this again. And now we have the results again, hopefully for LLM agents. So let's visit that page. And yeah, the results for all LLM agents. It says, so the first one is Wildfire GPT, Secret Collision, and such, OS Copilot, and so on. So yeah, that's correct. So it's now we just converted that simple stack into kind of a search engine for archive, basically. But it's still really not much of a deal, actually, because I could still go there, that page, I could change the search phrase by myself to LLM agents, and I could again see the same results just as listed here. So let's continue to make it a bit more sophisticated. And I would like you to pay attention to the links on the page. As you know, ModularMind can actually see the links on the page as well, not only the rendered page. So there are some links, and one of the links belong to the paths of the PDFs of the article. So if we visit this PDF, you'll see it's just the paper itself, Wildfire GPT, and every single result probably have that link attached to it at the search result with the search result. So now I want ModularMind, instead of just bringing me the authors, name of the authors, I wanted to bring the links to their PDFs. So let's continue. Let's edit the latest prompts with this and links to the PDFs of the articles. Now let's run this again. Now let's check this out if it's correct. Yeah, so it's successfully managed to find the links to their PDFs. As you can realize, I didn't tell it to how to find the PDF link because it's so many links in the page. Like even these authors have links to their own pages on Archive. So it successfully managed to link this particular links URLs with the title with the articles themselves. So now I have the list of the articles and their links to their PDFs. So what I want now is this. I want ModularMind to visit every single article, read the whole content, and summarize them for me. So let's just add another stack by adding a prompt and say, here are some articles and the links to their PDFs. And now connect this to the next one. So when I run this stack, the output will be delivered through the chain to the next stack so it can use that information. So, and before renaming, let's add another prompt saying, I want you to um, read the articles and summarize them. And let's now name it to summarize the articles. So again, this output just is just a placeholder for previous stacks output. And when I run this chain, the output of the first stack will be ready and delivered to the second stack, and the second stack can use that information to execute the task I gave it to. But at this point, I want to use GPT-4 Turbo because these articles are usually have a context length longer, even a lot longer than what GPT 3.5 has, which is 16K at this point. So I want to use GPT-4 Turbo, and it should be a lot better at summarizing tasks as well. So now let's run it one more time. Again, as you can see, it brings us the links to the articles. Let's check them out again if they're correct. Yeah. And now this stack will generate tasks to read the articles and summarize them all in parallel. So in a second, you'll see that it generates different tasks for each article. And now we have the tasks, 12 tasks for 12 articles. And they're all run in parallel, so it'll take more or less the same time for 12 articles it would take for a single one. So even before I finish my sentence, it's already started writing the results, the summarizations for each article. And we also have the links here so we can check out if it correctly visited the correct page. So yeah, there we have it. So this seemingly simple workflow managed to come up with the summarization reports of multiple, actually, in fact, 12 articles in this case. So you can actually use this kind of framework to supercharge your studies. And you can actually continue to improve this kind of workflow by, trying to fine tune your prompts to improve the stability or add additional steps like using all the summarizations of the articles and combine them into a single report, for example. So this is the way you can harness, these advanced capabilities of modular mind.